So I'm Shellshock. I just finished my second year of college, and this is the second video on MDiff, so if you haven't watched the first one, go back and do that. There are copies of the sheet and answers in the description. So I'm assuming that's below. Alright, so problem 1. You're asked to find the slope of the line tangent to the curve written there at the point written there. When it asks you the slope of the tangent line, that basically means take the derivative. So what's going to end up in this spot here will be your derivative. The important thing is that when you take the derivative of y, you have to remember the y primes. So y squared becomes 2y, y prime, 3y becomes 3y prime. And then you don't really have to isolate y prime, just plug in 1 for x and 2 for y, as you can see from those, and then solve for your y prime. And there's your answer. So for problem 2, you're asked to find the equation of the tangent line to the curve there at x equals 1. So you're given the equation. You have to find the point for y and the slope in order to be able to find the equation of the tangent line, because that's what you're asked to do. So here you're plugging in 1 for x, then you're going to solve for your y. And your y ends up being 2. So then you can go, you have point 1 comma 2. So then you can go and, okay, so now you have to find the slope. Your slope is still going to be the derivative, so you still have to remember the y primes, but in doing so, you need to remember to do the product rule and to distribute the negative. So then it becomes minus xy prime minus y. You then find your slope. And then where your slope would be here. And then you write the equation of the line in point slope form. Alright, so problem 3 is about the normal line to the curve. So again, you need to find the slope. But it's basically the same problem as problem 2, but instead you're finding the perpendicular line to the tangent line. So you're going to use the opposite reciprocal of that slope. Again, you need to be careful with your y primes. And remember the chain rule and the product rule with the derivative of e to the xy. So here, plug in your points for y and x, which is how you end up with e to the 0. Solve for your y prime, and that gives you your slope. But wait, you're not finished. So that gives you the slope for the equation of the tangent line. But like I said before, you need the opposite reciprocal of that slope. So your equation of your normal line is going to look like that. Right there. Okay, so problem 4. You're taking the second derivative, but they give you the first derivative, so you really only need to take one derivative. The derivative of cosine of y is minus sine of y, y prime. And because the y prime is dy dx, you can replace it at the very end with this piece here. So this here is what's in parentheses here. And then you're done. So, for problem 5, it's the same as 4, but you're going to treat your uppercase m like y. So really the derivative is negative 2 dm dr, and then you replace the dm dr with this piece right there. And you can find your second derivative. All right, in problem 6, you actually have to take 2 derivatives because you're not given the first derivative. So we're doing imp-diff. So the derivative of 5 plus y to the third is 3y squared y prime. So then you can isolate your y prime, and then you just take the second derivative. Remember the quotient rule and replace y prime with what you just solved for once you take the second derivative. So here, where you're taking the second derivative, and there's your y prime that you're just going to replace with this piece here. If you don't need to simplify, don't. If you do, then do. But really, you can multiply everything by y and get rid of fractions that way. There, that piece is here because you're plugging in for your y prime. It's really just a lot of simplification at this point. And there's your answer. And there's a more simplified version of your answer. All right, so now we're moving on to problem 7. So in part A, So in part A, you need to find and isolate y prime by taking the derivative and remembering to use the power rule. So there you've taken your derivative, being careful to use your power rule. Now you've isolated y prime, and there you go. So in part B, a vertical tangent line basically means the slope does not exist. So you set the denominator of the derivative, meaning the bottom of the fraction, equal to 0. Here, bottom of the fraction, equal to 0. And when you get that equation, plug it into the original equation in number 7, so up here. And you'll solve for the x values by factoring. So your answers end up being 2, 1 and -4, 1, where your answers are in x, y form. All right, so last question. Here I'm just drawing out where these points are relevant. Okay, last question. Consider the graph of that. You're being asked to find the derivative, aka y prime, and isolate it. So in this one, be careful with the product rule, because you have negative xy prime minus y for the derivative here. Move that. And now you've found your y prime, so you can move on to part B. You're doing a horizontal tangent line, so you want the slope to be 0. So set the numerator, or the top of the fraction, so this piece equal to 0. And then when you get y equals 2x, just plug it in the original equation. Don't draw a triangle. Plug it into the original equation in the problem 8, so up here. And then be careful because the y is being squared as well in the problem, which is why we end up with 4, I'm waiting for, right, 4x squared minus 2x squared, and then you can solve. This is where these are 4x squared minus 2x squared. I just didn't write it out. So then your points are square root of 5 over 3, 2 square root of 5 over 3, and negative square root of 5 over 3, comma, negative 2 square root of 5 over 3. And that's all. And here I'm just showing you where you plug these in to get these answers. And that's it. Thanks for watching.